Now let's look at the next two curves in there. Oh, see, now these are different. Okay, so these two have the same mean, and it's 0 for both of them, right? Because they have the same center, right? They're both centered, right? The high point for both of them is at the 0 mark, but the standard deviations are different. Standard deviation for the pink, oh, if I could fit this up, is 1. Standard deviation for the blue, if I could type correctly, is 2. Now, how do I know that? Okay, well, look at the pink curve. See how the center is 0? And then look at where the curve changes from being down to being up, concave down to concave up. It's right here at this mark. So you go follow the dotted line. Whoops, you don't do that. You follow the dotted line as it moves down. It's right here. And that has to be 1 because there's 0 and there's 2. And if you look at the blue curve, see where the dotted line is for that one? That's hitting it too. Cool. So they have the same mean, but different standard deviations. Right? One was skinny and one skinnier than the other. Right? The skinniness, fatness is what your standard deviation measures. Because standard deviation is a measure of spread, literally, like how spread out is your curve. And the mean is only a measure of where the center of the curve is. All right, cool, done with that. Next, what about the normal curve itself? All right, well, normal curve can actually be applied to all sorts of things, as long as the object, the variable that you're talking about, has this normal distribution. So it doesn't have to be like these numbers up here with the 0s and the 1s and the 2s. It can be all sorts of things. And then there's two ways to interpret the area under the curve. You could say the proportion of the population with the characteristic described by the interval of values, or you could say the probability of a randomly selected individual. So proportions really of a population is talking about a large group, and a probability is talking about an individual drawn at random. So the first thing they want us to do is draw a normal curve with the parameters label. I'm going to do this, but I'm going to do it in that program that I've got called Advanced Grapher. So hold tight, and I'm going to go make it. Poof. It's like magic for you guys, I know, but it took me a few minutes to make this, but there you go. All right, so you can see I've got a normal curve drawn. I've got the 2200 in the middle because that's the mean, and then I've labeled off each of the standard deviations. Now, of course, the curve technically continues on, but it's so little you can't really see it. But it keeps going past 2800 and past 1600, just FYI. Now they want me to shade the region that corresponds to less than 2,100 pounds. So let me bring this graph up here so you can see it a little bit better. Now less than 2,100, let me make it maximized. And again, you don't have to worry about how I'm doing this. This is a calculus thing, but if you're interested, I'm finding the integral. And I want to integrate from, it doesn't really matter, from 1,000 all the way up to 2,100, right? That was the thing. Oopsie, add graph. That's fine. There it is. Ta-da! All right, so I could technically copy that. Let me make it a little wider. And paste it in. There we go. There, it said shade the region. Done that. Now suppose you magically know that that area I just shaded is 0.3085, which, in case you missed it, the computer figured that out too. So provide two interpretations of this result. So I could say the chance of selecting a random giraffe that weighs less than 2,100 is 0.3085. Or I could say 30.85% of all giraffes weigh less than 2,100 pounds. There you go. There's your two interpretations as according to the blue box up above. I'm just following these two bullets.